Today we're going to talk about multiplying fractions and mixed numbers. So the first thing you need to know is the golden rule. The golden rule is you can only multiply simple fractions. What's a simple fraction? A simple fraction is made of only a numerator and a denominator. So for example, 5/8 would be a simple fraction because it's only a numerator and a denominator. Or 13/5 would also be a simple fraction because it just has a numerator and a denominator. A non-example of a simple fraction would be 1 5/8 or 2.5 because there's both a fraction and a whole number. So that goes to, are improper fractions simple fractions? They absolutely are. So we need to use only simple fractions when we're multiplying fractions and mixed numbers. So next question, do I need an LCD for multiplying? The answer to that is no, I do not, because we multiply and divide the numerators and the denominators. For example, we have 1/3 times 5/8. We are multiplying across because we have 1/3 and we're making 5/8 of that. Five, 6, I think that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Clearly I'm not very good at making fraction bars even, but you get the gist. So on this one, I think I'm going to use a lighter color. On this one, we go the opposite direction and we have 1, 2, 3, 4, 5. So what we've done is we've taken 5/8 of 1/3. And what you can see is we have an overlap of these two colors right here. So now we have 1, 2, 3, 4, 5 pieces of our total 24. So as you can see, when we do this, this is our visual, this is what's happening. We are just multiplying the numerators and the denominators across. So we just multiply across and simplify. Sometimes though, we can simplify on the front end instead of the back end. So this fraction didn't really need to be simplified. But what happens when we have one that does? So we've got 3/8, let's look at this next one, times 16 out of 27. So we've got 3/8 times 16 out of 27. We would multiply that across. So 3 times 16 is 48, and 27 times 8 is 216. That is a really big number, and we have to simplify it. Well, I don't know my multiples of 48 or 216, so I'm going to start with 2 because I know that both of these are even numbers. So that gives me 24 out of 108. And then I know that 24 is a multiple of 12, and so is 108, so I can divide both of these by 12, and that gives me 2/9. Now, if I didn't know my multiples of 12, I might have to continue dividing by 2 until I found, and then 3, and then 2 again, or divided by 2 and divided by 6 until I came to my simplest fraction. Now, there's an easier way to do this because those numbers can get super, super big, where we simplify on the front end instead of on the back end. So what we're going to do is we're going to look at this problem again. So if I look at across from 8, I have 8 and 16. Those fractions have common denominators. 8 or common factors, sorry. These have common factors. 8 is a factor of 16 and 8 is a factor of 8. So I can divide both of these numbers by 8. This is called cross factoring. This becomes 1 and this becomes 2. And I can do the same thing on this side. 27, I can divide by 3 and I can divide by 3. This becomes 1 and this becomes 9. Now when I multiply 1 times 2 and 1 times 9, I end up with 2 ninths. The same answer I got up here. Always use the GCF, or the greatest common factor, when cross factoring. And like I said, cross factoring just makes the work easier and it makes things a lot faster when you have those big numbers and you're multiplying. All right, let's look at another problem. So we've got 3/11 times 2 ninths. Now, you may not always be able to cross factor. If we look at 2 and 11, we can see that 2 is not a factor of 11. So I can't simplify here. But I do see that 3 is a factor of 9, so I can simplify, and this becomes 1, and this becomes 3 because I divided both of those numbers by 3. And then I just multiply across. This is 2, and 3 times 11 is 33. And that is multiplying with fractions. Now, what do I do when I have whole numbers? Okay, so a whole number, I have 8 times 5/7, or 8 groups of 5/7. We need to put in a placeholder, just like we do with decimals, just like we do with whole numbers, where we use a 0 as a placeholder when we're multiplying or adding and subtracting decimals or multiplying and dividing decimals, we use 0 as a placeholder. In this case, we're using 1 as a placeholder because when I take 8 and I divide it by 1, I still get 8. So the purpose of our placeholder is to hold place value without changing the value of the number. And then we just multiply across. So 8 times 5 is 40, and 7 times 1 is 7. Now, I have an improper fraction. I'm not allowed to leave it that way because I need to simplify. So I'm going to simplify this number by dividing 7 by 40, which gives me 5. So if I'm looking at the math, I have got 40 and I've got 7. 7 comes out of 45 times. And I have 5 left over, so that means that I have 5/7. All right, let's look at another whole number. So we've got 3/5 times 10. So we're going to add in our placeholder of 1, and I'm going to look to see if I can cross simplify. 5 and 10 are factors of each, or 5 is a factor of 10, so I'm going to divide by 5, and it's going to give me 1. And this gives me 5. And I cannot cross factor here because 3 is not a multiple of 1, and I can't divide 1 by 3. So now I'm just going to multiply. So 3 times 5 is 15 over 1, which equals 15. Oh, I did that wrong. This is 2. This is 30. And this is this is 6. Oh my goodness gracious, I totally messed this up. You know what? We all make mistakes, and that's what we need to show. So this should be 5 comes out of 10 2 times. My apologies, friends. So 3 times 2 would be 6, which equals 6 out of 1, or 6. Like I said, we all make mistakes, and sometimes our brains are just not there. All right, let's look at another one and see if I can do it without messing up. All right, so we've got 5 times 3/5. We're going to put our 1 underneath our 5 as our placeholder. We can see that 5 cancels each other out. They divide by and they equal 1. And then 1 times 3 is 3, and 1 times 1 is 1, which means our answer is 3. All right, let's move on to mixed numbers. So just like we said earlier, where we can only multiply simple fractions, when we have a fraction with a mixed number, or we have a mixed number, or a fraction with a whole number, 3 2/3. All right, those fractions or those mixed numbers have to become improper fractions before we can do anything with them. So we're going to go ahead and turn those into improper fractions. So that would be 5/2 times 11/3. And then we're going to look to see if we can cross factor. 5 and 3 are not factors of each other, they're both prime, and 2 and 11 are not factors of each other, they're both prime. So I just have to multiply. So this would be 55/6, and then I turn that into a mixed number. I turn it back into a mixed number by dividing. So I'm going to take 55 and divide it by 6, which gives me 9 with 1 left over. So my answer would be 9 1/6. All right, let's look at another one. We have one more, 13 1/2. Times, maybe we're going to do 2 more, times 3 5/9. So again, we're going to turn these into mixed numbers. So 2 times 13 is 26, plus 1 is 27, over 2, times 27 plus 5 would be 32. It's late tonight, over 9. And then I look for cross-factoring opportunities. So 27 and 9, 9 can come out of 27 3 times, and 2 can come out of 32 16 times. So now we just multiply 3 times 16, which gives me 48. And that is multiplying fractions and mixed numbers.